So, good afternoon, students. Today, I'm going to solve question number 25 from IIT JAM 2021. So, in this question, we have given a capacitor of 10 microfarad, and across these two capacitor, I have two batteries of 20 volts and 10 volts. Okay. So, in the beginning, this switch S is open, and once you switch off this switch, okay, and then he's asking what is the voltage across this capacitor after t is equal to 2.4 millisecond. Okay, so how to do this? So first of all, the voltage C at a capacitor is given by V naught plus V at t is equal to 0 plus V infinite minus V0 minus V infinite into e power minus t upon RC. Okay. So now in order to calculate the voltage across this capacitor after t is equal to 2.4 millisecond, I need to calculate what is the voltage at t is equal to 0 and what is the voltage at v equal to infinite. That means, so how to calculate v equal to 0? So in the beginning, say less t when t is less than 0. Okay, because we are making this switch off at t is equal to 0. So what is the condition before t is equal to 0? Okay, so before t is equal to 0, this switch is open, so no current is flowing through this circuit. Okay, so now we'll use only this circuit. Okay, so in this circuit, if I use this circuit, so at t less than 0 or t before t is equal to 0, I have 4 kilo ohm resistance, and then I have this capacitor. Okay, so now what will happen? This is simple RC circuit. Okay, now this capacitor will charge, and we know for DC circuit the capacitor acts as a open terminals. Okay, so once this will charge, okay, up to 20 volts. Okay, after that there will be no current in the circuit, so this terminal, this capacitor act as a open circuit. Okay, now what is the voltage across this capacitor? We can calculate. So VC, so now we know, so all the voltage will be across this C. Okay, so that means V is equal to 0 before we open, just before t is equal to 0, we close the switch, the voltage across this capacitor is 20 volts. Okay, now after that, what we'll do, after this, after t is equal to 0, I switch off this, I close this switch. Okay, so once I close this switch, okay, now in second case, what is the voltage across this capacitor? Okay, so again this capacitor will get charged. Okay, and it will behave like a open switch. Okay, so now I need to calculate across voltage across this capacitor. Okay, so let's say voltage on this point is V. Okay, now I can apply KCL here. So I know this is VC. So VC minus 20 upon 4 kilo ohm. Okay, plus VC minus plus 10 upon 6 kilo ohm equals to 0. I'm applying KCL. Okay, applying KCL. Okay, say this point is C. So I'm applying KCL at point C. Okay, so if I solve this one, okay, so kilo ohm cancel. Okay, this will give me 6 VC minus 120 plus 4 VC plus 40 equals to 0. And if I solve this one again, this will give me 10 VC equal to minus 120 plus 40, it will be minus 80 equal to, if we bring here, it will be 80. So this implies VC equal to 8 volts. Okay, so this VC, okay, is when after closing this switch. Okay, so this VC is equal to my VC infinite, okay, or V infinite. This value is 8 volts. Okay, so now I know what is the V0. V0 is my 20 volts. Okay, V0 is 20 volts, and V infinite is my 8 volts. Okay, now what I need to do, I need to calculate this time constant for this circuit RC. Okay, so in order to calculate RC across this capacitor, okay, what I need to know, what I need to do, I need to make these batteries, okay, as a short circuit. I'm applying Thevenin formula. Okay, so this becomes short circuit. Now if I see the resistance across this this capacitor terminals, okay, so these 4 and 6 ohms are in parallel. Okay, so R equivalent will be now 4 kilo ohm into 6 kilo ohm upon 10 kilo ohm. So this will become kilo ohm cancel. So this will give me 2.4 kilo ohm. Okay, that means my R equivalent is now 2.4 kilo ohm. Capacitance value is already given. The C value is already given 10 microfarad. So here I have a C, okay, whose value is 10 microfarad. Okay, here I have a battery of 20 volts. Okay, here I have one more battery of 10 volts. Okay, so now what will be the RC time constant? Time constant will be R equivalent into C. So if I calculate R equivalent, okay, so R equivalent is 2.4 kilo ohm. C value is 10 microfarad. So this will give me 2.4 into 24 into 10 raised to power minus 3 seconds. Okay, that means 24 milliseconds. Okay, now I can apply this, use this formula and calculate what is the value of this VC. Okay, so now this VC will be V0. So V0 is, sorry, this is V infinite. Okay, so V infinite is my 8 volts. Okay, then V0 is 20 volts minus V infinite is 8 volts exponential minus T is 24 milliseconds, or okay, T is 2.4 milliseconds, and RC value is 24 milliseconds. Okay, so now if I solve this one, this will give me 8 plus 20 minus 8, 12. Okay, e power, so 10 to the power minus it cancel, and this will give me e power minus 1 by 10. Okay, so this is 8 plus 12, and e power minus 1 by 10 value is 0.904. Okay, if I solve this one, it will give me 8. So 8 plus 12 into 0.9, this will give me 10.848. Okay, so if I solve this one, it will give me 18.848 volts. Okay, so this is your answer. Now I can also solve this question slightly different technique. Okay, I can use source transformation because I have voltage and we have series resistance 6 kilo ohm. So I can convert these voltage sources into current sources, and I can try to bring this circuit, okay, into simple RC circuit. So how to do this? So I know my V0, okay, V0 is 20 volts. Now I will try to bring this circuit into simple RC circuit. So what I'll do, I will convert this voltage source into current source. So this is voltage 10. Okay, so the current value will be 10 upon 6 kilo ohm. Okay, so this will give me 5 by 3 into 10 raised to power minus 3. That is 1, okay, so 1.66 milliampere. Okay, that means now I can convert this battery into a current source of 1.66 milliampere. Okay, similarly I can convert this voltage into current source of 20 divided by 4, 5 milliampere. Okay, so what I'll do, I apply source transformation technique. Okay, and I will convert, this will become my 5 milliampere source. Okay, here I have 4 kilo ohm resistance. Similarly, now what I'll do, this is my 1.66. Okay, current will be always negative to, sign will be always negative to positive. This will be current of 1.66 milliampere. Okay, and I have one resistance of 6 kilo ohm. Okay, now because now what I can do, because these two sources are connected. Okay, so now what I can do, I can first of all, so this resistance will go into parallel. Okay, so this will go into parallel because I'm changing source to current source. So this become 4 kilo ohm. Okay, similarly this resistance will also go into parallel. So this become 6 kilo ohm. Okay, now these two resistors are in parallel. Okay, so this circuit simplifies to the equivalent of these two resistance. It will be this current source. Okay, and this will become 4 into 6, equivalent will be 2.4. So this become 2.4 kilo ohm resistance. Here I have a 5 milliampere current source. Across this I have a capacitor of 10 microfarad, and again this I have one more current source of 1.66 milliampere. Okay, now these two sources are in parallel, so I can make it single source. So if I again change this one, so 5 minus 1.66. Okay, so 5 minus 1.66. Okay, this will give me 3.33 milliampere current source. Okay, so now I can change this circuit as this is my current source of 3.33 milliampere. Okay, and parallel to this we have 2.4 kilo ohm resistance. Okay, and parallel to this I have one capacitor of 10 microfarads. Okay, now this current source and this is a parallel resistance. Okay, again I can apply the source transformation technique. Okay, and I can convert this current source into again a voltage source. Okay, so if I again apply source transformation technique, okay, I can solve this 2.4 into 3.3. This will give me 8 volts. Okay, and this resistance now will become in series. Okay, and this is my capacitance. So now this becomes simple RC circuit. Okay, this becomes simple RC circuit, 2.4 kilo ohm and 8 volts. Okay, so we know from like here the voltage across this capacitor was 20 volts. Similarly here at final stage the voltage across this C will be 8 volts because this capacitor will charge up to 8 volts and then there will be zero conductor circuit. So this will behave like an open circuit. Okay, and all the voltage will be across this C. Okay, so now V0 is 20, V infinite is 80 volts. Okay, now so similarly now we can apply this formula here. Okay, we know R value, R equivalent. Okay, we know C value. Okay, we know time. So we can solve like earlier we have done, and we can get the answer. Okay, so V infinite is 8. Okay, again V0, what we done the same before earlier. Okay, 20 minus 8 e power minus, this is 2.4, and this is 24 into 10 raised to power minus 3. So this will give me same answer, 18.848 volts. Okay, so in this way we can apply source transformation and we will try to bring this circuit in a simple RC circuit, and then we can use, we can easily calculate what is the R equivalent value. Okay, and we can calculate the time constant. So in these questions, what I supposed to do, first of all, I need to calculate what is the voltage at time before we close the switch. That means before t is equal to 0. Okay, t is equal to 0, and then what is the final voltage, that is called V infinite, and I need to calculate the time constant RC. Okay, so once know these three things, we can solve this type of problems. Okay, thank you very much.